All right, peeps, we are in the systems unit. Moving on to learning target 5, solving linear systems of equations that model a real-world context, meaning they have a story problem that goes with them. Okay, Miss Aaron's class, if you are watching this, welcome. Hansen's class, I'm sorry, this is up so late. But let's start with the first one. Here's what we're going to do with this first equation, or this first problem. We're going to cross it off because I don't like it. It turns out that you don't really use systems with it. I don't know what we were thinking when we put it on your note sheet, and it's pretty stupid. So if you want to try that just for fun, go for it, but we're not going to talk about it right now. We might come back to it. We're going to move to the second problem, is that Stefan is going to sell tickets to a performance, okay, at the school that he goes to. So they've already sold these tickets, and we have 2 days of data to look at here, okay? So on the first day, the ticket sales, they sold 3 senior citizen tickets and 1 child ticket, so not many people are coming, and they sold those for a total of $38, okay? The second day, there was $52 spent on 3 senior citizen tickets again, but then this time 2 child tickets. Now, notice that you might be saying, well, there's 3 and 3, and there's different prices. It's because we have to find out how much that child ticket is. What we don't know, our unknowns here, are the price of each of these tickets. How much does a senior ticket cost, and how much does a child ticket cost? So we have 2 days, we have 2 equations that are going to share variables. So our first equation would be for the first day. We know that $38 was spent on 3 senior tickets, I'm just going to use S, plus 1 child ticket. And we know day 2, $52 were spent on 3 senior tickets and 2 children tickets. Okay? So we can either solve this using substitution, or we can solve it using elimination. I think elimination is better here because look, we have 3 and 3. Let's just eliminate one of those by making this first equation negative. Okay? And if we do that, then I can just make everything in it negative so that it's all positive. So that becomes a negative, that becomes a negative, and that becomes a negative. And then let's use elimination. So what we can do here is negative 38 and 52 is going to give us 14. Our 3 S's are going to cancel, and we're left with 1 C. So what that means is that the child's ticket was $14. Okay, now that we have the child's ticket, we can plug it back into either one of these equations. Let's use the less complicated one. And let's say that $38 is going to equal 3 S's plus 1 child, so plus 14. So if we minus 14 from both sides, then we have 24 equals 3 senior citizen tickets, and we divide by 3. And we get that $8 is the cost of each senior citizen ticket. Okay? So now you might be wondering, do we write this as a point? Do I write 14, 8? Well, I mean, you could, but that would be on a graph where we had the children's tickets here and the adults, or the senior citizens tickets here. In the real world problems, sometimes it's just better to say, okay, the child's ticket, and maybe write it out. The child's ticket cost $14, the senior citizen ticket cost $8. So you have more of an answer and less of an ordered pair. Because we might not be looking at 2 lines, because a graph might not be applicable here. It's always possible, but it might not be something that you're looking at if you don't need to. Okay? So you'll notice that both of these equations are given to you in standard form. We will see some examples where we have y equals form. So if you think back to some real world examples of, we might have 2 people that start at different spots, like Harry and Sally. That would be a real life situation where you have 2 y equals equations. You had Harry was running like 1.1, maybe 1.25 miles every minute, or no, 0.125 miles every minute, and one of them was running 0.1 miles every minute. And then where they met was the solution to the system. Okay, that would be a real world context. We won't go over specifically one of those, but that would be a real world context that would be given with slope-intercept form, two equations in slope-intercept form. These are the more difficult problems, so these are why we wanted you to look at those. For your before class problem, you have Jonathan is really hungry. He spent $45 on hamburgers and hot dogs. Okay, hamburgers cost $3. Hot dogs cost $3. Hamburgers cost $4. Jonathan buys 12 food items. So you're given some information here. You have two equations. Think of one of your equations as a money equation. Okay, so what are you spending? What's your total amount spent? How much are you spending on each? And think of the other equation as just how much food do you have. Okay, your variables are hamburgers and hot dogs. Okay, because that's what you don't know. You don't know how many of each did he buy. So those are your variables. Try that before class. With that in mind, since we didn't do a whole lot in this video, here's what I want you to do. I want you to, right below this video, click on this Khan Academy video in practice, and I want you to go and listen to some of his videos and practice some of these problems, okay? So the little play button is videos, the practice is problems. So try these before class, okay?